So we have one more talk before we break for lunch. The last talk was super exciting. I'm expecting the same from this one. We've got Or from Wix.com going to give us a talk on moving to Bazel-based CI system. Come on up, Or.
Hi, everyone. Is it on? Yeah. So with a show of hands, who here is familiar with the experience of taking a long break because you're waiting for your build to finish, because the build takes a lot of time? Yeah. Yeah, we all have it, right? We all have those things that we do at the office while we're on pending mode, right? Taking a coffee break, checking your email. I personally call my mom. And in many companies, this is what developers do while waiting for the build to happen. So hello, everyone. I'm Or. I'm a backend engineer at Wix CI group. I came here all the way from Tel Aviv. I'm super excited to be here on stage, and I'm really happy to see how the community grows from year to year. A little bit about myself. I was fortunate to start my career working side by side with a classic build manager who taught me the joy of Ant and Makefile. Since then, I've built several Maven CI pipelines again and again, and then moved to doing some backend engineering. 3 years ago, I joined Wix, and I was happy to combine my two passions, doing backend engineer for the CI system. At Wix, we needed to bring distributed backend systems into the CI domain because traditional tools did not work well with our side. So we moved the backend build system from Maven to Bazel, and we're quite happy about it. From long-running build that made us wait and wait and wait and switch context and eventually failed, to speedy build that just work. And I'm here to talk with you about the process of getting there. Before we begin, let's agree on a simple metaphor for a build system. An assembly line. The input is our code base and the build definition. The machinery is the build server and the build tool. And the outputs are the deployables and the feedback back to the developer. It's quite simple to understand, right? We require the system to be fast, reliable, and efficient. But let's look at the Wix backend build system situation in 2017. We had about 5 million lines of code, mostly Scala, over 1,000 Git repositories, about 150 developers. For build tool, we use Maven, so snapshot dependencies between 2,000 Maven modules. And we use TeamCD for the build server. So each Maven module got its own TeamCD configuration, which is the equivalent of Jenkins' job. We applied pessimistic lock, so whenever a module was built-in or broken, any module that depended on it was actually blocked. And we had a real big problem, because this did not work well with our size. Many builds were broken, breaking downstream builds. In order to get my feedback, I had to wait sometimes over an hour. In order to get my deployable ready, I had to wait many hours today. And this is not exactly what the CI system should do, right? We're supposed to improve the dev velocity. And those are just examples from messages we got on our CI Slack channels. Frustrated the developers asking about their builds. CI was marked as one of the biggest bottlenecks in releasing a new feature. And we knew that something must be done. We knew that we already exhausted any options to optimize within the system we had. And we need to look for something new. We considered moving to SBT, to Gradle. But given how Wix is growing from year to year, we wanted something that would still work with 10 times, 20 times more scale. So a snap to the present, 2019, we completely changed the machinery. We completely changed the CI system to work with Bazel. We're very happy to say that our builds are mostly stable. In order to get my feedback, I need to wait 5 to 10 minutes, not more. To get my deployable ready, 15 to 25 minutes. In the next 2 months, it's going to be even half of it, thanks to optimization that we're working on these days. And yeah, we're quite happy about it. We made a long way getting from this to that, moving to Bazel. And we had a lot of failures along the way. Thanks, Jeff, for the talk. And we had a lot of learnings along the way. So I'm here to share with you 6 key learnings that might help you when you're migrating your system to Bazel. So let's begin. Number one is use a migration tool. If you want to run Bazel on your code base, you need to have some Bazel files, right? Build files, workspace file. And you can write those manually. Let's understand what it means to write those manually. Let's take a Maven repository, a very simple Maven repository. 2 modules, a core and a server, some main code and some test code. The first thing we want to do is to choose the build granularity. That is, how many source files will be included in a single build unit. You can go very coarse grain like Maven does, so group together all of the main code and the test code. You can go very fine grain, so a single build unit per source file. It's all a matter of how much you want to gain from Bazel parallel execution and cache. At Wix, we chose the 1-1-1 strategy, so it's the mid ground. 1 target per 1 directory representing a single Java package. Next, we want to understand what Bazel rule does each build unit represent. Java library, Java test, maybe it's the image, maybe it's the deployable that you want to get at the end. And then we want to start working on the dependencies. Start with the interdependencies, dependencies between the internal targets, and external dependencies, dependencies, in this case, on external Maven binaries. And look here, we have dependencies on JUnit and Jetty, but foo core depends on Guava 20, and foo server depends on Guava 28. And if you know about the JVM world, you know that this is not a healthy situation because you can get failures in production or in test runtime. So part of the migration for us was to align third party to all use the same version of each dependency. So now that you know the dependency and the targets, you're done. You can start writing your workspace file and build files. But we understood at Wix that this is not how a workspace looks like. This is not how a code base looks like. It's more like this, right? This is so we actually wrote a tool that will do everything for us automatically and generate our build files and workspace file. Using some heuristics and code analysis tools, it will generate the code graph, reduce it to targets graph, then we'll deal with all the dependencies, the third-party dependencies, and write the Bazel files, the build files, the workspace file. I'm happy to say that this year we open sourced it under the name of Exodus, so you're more than welcome to try it out. Let us know how it works for you and contribute, make it work for other languages, for other build tools. We'll be very happy to help you out. But it's a tool that works with heuristics, and it doesn't really change your source files. So in a lot of cases, the generated Bazel workspace would not pass Bazel build and Bazel test. So you would still need to bring some experienced developers, we call them the migration trustees, to massage the migration result and make those steps pass. It's not as hard work as writing the Bazel files from scratch, but it does require some skills, because sometimes you need to add missing dependencies that Exodus missed, or you want to change the code. Maybe the code would not compile once you make all the code work with a single version of Guava. Or you find out that you have tests that try to explicitly read from paths that are only available during Maven test runtime, like SRC test resources, test that tries to download stuff from the internet during test runtime. And you know that in Bazel, you run everything in hermetic way, so there's no internet access during test runtime. And those are just examples. We have a full page of troubleshooting Exodus results. The rule of thumb is that the more technical depth your project have, the more work the Bazel trustees would have to do. So let's look at the process again. The migration trustees massage the result. Now we have Bazel build and Bazel test pass. At Wix, it wasn't enough for us. We needed a way to make sure that we don't lose anything on the way, that we didn't miss anything on the way. And the way we chose to check it was to actually write a comparison script that scrapes through the Maven test result and the Bazel test result and compare all the test cases. You must imagine how happy was the backend developer that got the job to write this comparison script that compares a bunch of XML to a bunch of XML with a slightly different format. But we did it. So let's have a look at the final process. The comparison script passed, and then we consider the repo as Bazel validated, and we can start working with Bazel. In many cases, we had to reiterate on the process. So in order for Exodus not to do the same mistakes again and again, we added override mechanisms. So the migration trustees can hint Exodus to do some additional steps at the end of the automatic migration. So I really think that if you can use a migration tool to generate your Bazel file, this can really boost your migration project. Number 2, measure your system. It's kind of trivial, but you need to remember that you're working on optimizing a system, and you want to measure your current system. You want to measure the new one. A story from 2017. We took Wix framework, one of the larger Git repositories we had, with over 100,000 lines of code, 200 Maven modules. Framework at Wix is basically a set of libraries and utilities that are used throughout all of our microservices. And we migrated it with Exodus. We got to 2,300 Bazel targets. And we were very happy to show that after running Bazel several times, the average run of Bazel takes 5 minutes, incremental build. And to get a correct build in Maven, to run Maven from the top level directory, it took us 45 minutes. So that's amazing, right? It was a really good seller in the organization to say, hey, Bazel is amazing. But the truth is that it's not a good enough way to measure the whole build system. Because in CI, in the Maven CI, we didn't really run Maven from the top level. We did try to optimize and parallel as much as we could. And also for framework, we didn't really have deployables. And part of part of how you want to measure the CI system is how much time it takes for a deployable to be ready. So in a hindsight, this is what we would have done to show improvement. So for each artifact, for each deployable, I would check how much time it takes from a push to a deployable. And you want to check it per commit, because you want to compare apples to apples. You don't want to compare how much time it took to a change in a root library that affects the whole build tree and a leaf library that affects only itself. Also, you want to check the stability rate, and I'll explain. Let's say that I'm working on a new feature on a super artifact. I'm working locally, and then I want to merge my changes to master, and master is broken. I'm basically blocked, right? I need to wait for master to be green, for someone to fix my master before I can merge my change. So given a time frame, you want to check how much of it your master was green and ready to be changed. We actually used the fact that Bazel was so fast, and we used the remote cache to introduce the pre-check mechanism. So we really improved on that metric alone. So you're going to invest a lot of time and effort in your migration project. Make sure to invest also some time in measurement system that will measure the old CI pipeline and the new CI pipeline. And it will also benefit you for the future if you want to understand where you can improve. Number 3, local dev experience. Don't forget your users. When we started the project, we thought Bazel would be amazing for the CI system. And when you run Bazel from command line, it takes us 5 minutes, right? Not 45 minutes, 5 minutes. Everything would be amazing. Developers would be happy. But when we started to get more and more users, we started to get a lot of rejects, users that came to us super angry saying, hey, the experience with IntelliJ sucks. How do I handle all of those build files? Dependency management is so hard now. And I get red codes, and the code completion isn't correct. And refactoring is basically impossible. We also thought that all of our developers were going to use the same remote cache. And we found out that, and we're using at Wix local builds. So we found out that with macOS, it's not that easy. You have to manage all of the tools, the Xcode version, the CLang version. So we actually started the project with developers not using the same remote cache, and they all had to build locally. One team leader came to me and said, wow, that's amazing that you made the CI so fast, but now it takes me 3 times, 4 times as much to develop a feature locally. So it didn't really improve on anything. So eventually, a good end to the story, eventually at Wix, we made sure that we'll do proper Bazel training for the whole R&D group. We made sure that we're really on top of any IntelliJ issue, and we reported anything to the Bazel IntelliJ repository. And when it was possible, we also contributed solutions ourselves. Whenever we hit a wall, we just develop solutions ourselves, internal solutions. Today at Wix, we have a whole team that is in charge for the local dev experience with Bazel, doing tooling alignment, making sure that all of the developers can use dev cache safely. And we wrote a set of enhancement and tooling to make the work inside IntelliJ with Bazel much better. Tomorrow there's going to be a talk just about that by Itai Zeidman, so I really recommend you to go. I can say that today the local experience isn't perfect. It's not fantastic, but it is OK. And it's really worth the trade-off of moving to faster build on CI and locally. So yeah, number 3 is think local dev experience. Number 4, introduce a new CI pipeline, but keep the old one. And I'll explain. Let's talk 60 seconds about how a change gets from the developer to production at Wix. Unlike other companies or some companies, we don't have code drops or iterations. And the decision on when to deploy a change to production is solely on the developer. The developer pushes code to Git. It will kick off the CI pipeline that will create an artifact. And then a developer can go to our deployment back office, a system that we developed in the CI group, and decide whether to send a canary of this version or to GA it, to put it in all servers, or to roll back to put the previous version. So the speed of this process really depends on the speed of this part, right, the CI pipeline. And this part was bad for us. This part was broken, was slow. We needed to replace that. And we did. We thought of, OK, let's do a whole new process that is Bazel-based. It's going to use Bazel remote cache and remote execution. We're going to protect master from being broken. We will also have an automatic discovery of any deployable, because unlike TeamCity, we didn't have one job per module. We had one job per repo. So we need to discover all deployables inside that repo. We're going to replace the build server to be cloud-based, so no agent limit, no build queue. And we took this amazing pipeline and we placed it in parallel to the old CI pipeline. So any change actually triggered both of the pipeline and created 2 separate artifacts, one that is Bazel-based and one that is Maven-based. And then the developer could go to our deployment back office and with a click of a button change whether she wants to take the deployable from Bazel or from Maven. She could just go back. And this proved itself to be very good because the developer was confident to know that she can move whenever she's ready. And if there was any issue, she could roll back and move back to Maven and fix the Bazel build offline. So I think run parallel CI pipelines and until you're ready to discard your old one. Moving on to number 5. Now, number 5 talks about optimizing your CI for speed. And this is actually relevant for those of you who already moved to work with Bazel. So we all know that Bazel is fast, right? But at Wix, we wanted to make it faster. We wanted to make it as fast as possible. And when we started, when we started the CI, we said, OK, we're going to use Bazel remote cache, remote execution, and this would create an amazing CI build. It's going to be super fast. But then we started the system, and we noticed that even for a fully cached build, we had to wait 5 to 8 minutes. And at this point, we were devastated. Like we said, OK, what are we going to do? This is we wanted to show that Bazel is fast, but 5 to 10 minutes for a fully cached build, this is not what we expected. And the reason for that is very simple. The reason for that is that we had a lot of third-party dependencies. So every time we ran a build on a ephemeral machine. Every time we ran a build, it had to re-download all the Maven binaries and Docker images. And the solution for that is simple. We need to bring two directories that are pre-populated with the Docker images and Maven binaries. The repository cache is a feature of Bazel. The Docker cache is a feature that Wix contributed to the open source of rules Docker and container registry. And once you have those folders ready, before you start running Bazel, you can save the time on fetching those dependencies. Another thing is if you dig into Bazel documentation, you'll find that you have many flags that you can that you can add to your build and save many minutes of your builds. For instance, builds without the byte, since we're building with remote execution, we can save time on downloading intermediate results between of actions. Or if you find that you spend a lot of time computing the digests of your input, if you add a flag of multi-thread digest, this can save you some time. On that point, I think it was very beneficial for Wix to be a very active member of the community. Wix is a co-maintainer of Rule Scala. We make sure that we're very much on top of any issue, any new feature that's about to happen. Whenever there's a new release candidate, we make sure that we test it against all of our repositories. I really think that if you're planning to go on to use Bazel, become a Bazel activist. It can really work well for you. So number 5 is optimize for speed. We're getting to our last one. Number 6 talks about migrating a poly repo. Because migrating a single repo is one story, but migrating a poly repo is a whole different story. But it is possible, and let me tell you that story. When you read about Bazel, you know that it's really good to use Bazel with a monorepository, right? Put all of your code in a single repository. The developers can find everything in a single place. A single Bazel execution would test everything, and then you can work with a single or very few CI jobs. And we tried it out. We tried to put all of Wix backend code in a single Git repository, and we got a hard reject from Git. Just running Git status on the repository took us 15 minutes. So we know that it's possible. We know that Twitter does it, and Microsoft has a solution for this. But when we started, all of this was very much premature. And I think until today, correct me if I'm wrong, but I think until today it's not possible to do it in GitHub. So we couldn't do that with Git. So we thought, OK, maybe we'll just move out of Git. Maybe we'll just do monorepo on a different solution. But then we got a hard reject from a developer saying, hey, you're changing too much. The experience with a new build tool, the IDE, no way you're going to change Git. So really, our only option was to continue working with a lot of repos with Bazel on Git. But of course, we didn't want to have the 1,000 repository model. We did want to have as much code as possible in a single repository for a single Bazel invocation to test as much as possible. So after some internal friendly debates, we managed to consolidate 1,000 repos to 50 repos. Debates on, yeah, I want to be with him, and I want to be with her. And we got to about 50 repositories. And our goal was to work in a virtual monorepository mode. I'll explain what it means. I know if all of you know how to read Bazel targets. I hope you do. But this is a Java library that has 2 dependencies. The first dependency is a local dependency. It starts with // and it means that it comes from the same repository. The second is an external source dependency. It starts with this add framework. And this add framework name is defined in the workspace level. See, this add framework defined as a Git repository with a Git URL and a commit. The idea of a virtual monorepo is to have this commit move around automatically. How we implemented it, last year there was a talk, again, by Ty Zeidman in BazelCon that talks about our implementation. But in a nutshell, we have a server called Virtual Monorepo Server that magically knows all of Wix repository and the latest head commits. We have a Bazel wrapper that talks with this server, and before the build begins, generates an external repo BZL file. And our workspace files just load those definitions. That's very simple to understand. It's super simplified. Our CI builds generate this file with every build, so every build runs with the latest version of everything. And the developers can regenerate this file manually or whenever they switch a branch. So back to our story. We didn't really have a single migration with Exodus. We had over 50 migrations with Exodus. And we had a problem because, like I described at the beginning, part of the migration is to extract the external dependencies, all those Maven modules that are not part of the same repo, and treat them as an external binary dependencies. This includes common dependencies that you all know, Guava, Commons, JUnit, but also it included internal libraries with snapshot dependencies. So we had all of those labels that represent third-party binary dependencies like Com, Google, Guava, but we also had all of those labels that represented, we call them second-party dependencies, but it was the snapshot dependency. And this was good because it allowed each repo to migrate without depending on the migration of other repository. And then to onboard the new CI pipeline, get faster build, get faster feedback. But the problem was that even if my repo already migrated to Bazel, I had to keep my Maven build green so external consumers can still consume my snapshot dependencies. Also, the Bazel builds depend on the Maven build. And every build got a different set of snapshot dependencies. This is how snapshot mechanism work with Maven. And locally, since Bazel doesn't really know the concept of snapshot, then I would download the snapshot the first time I would run Maven, and I would just continue using the same library forever until I would clean up those snapshots and force Bazel to re-download the latest snapshot. So we provided our developers a custom script that would clean all the snapshots, and it created a lot of confusion. It was really not a good situation to be in. We had to wait until all repositories would go through the migration in isolation mode, that is how we called it, before we could start dealing with all of those snapshot dependencies. We wanted to break the connection between our Bazel builds and our Maven builds. And this is basically what we wanted to happen. We wanted to take all of those second-party labels that map to snapshot dependencies and change them to external source dependency. So this @framework // blah, blah, blah. We called it moving from isolation mode to social mode. One naive solution is to do basically that, to just go over all of the build files and change those labels according to the mapping that we already knew. But the problem was that this involved touching a lot of build files, was very complex, and if there was any issue with this at the end, it was very hard to revert this, right? So eventually, we came up with a clever solution. We used the fact that this ComWix framework is just a logical name that's defined on the workspace level. And we knew that we can map this name to an external binary rule that downloads the snapshot, but we can also map it to a different rule. And we wrote our own custom rule that does a very simple thing, just exports those external source dependency. So we didn't have to change any build files. It was only a matter of choosing what kind of rule we're gonna define in the workspace level. And for each of the second-party label, we had this decision tree on whether The current repo is part of social mode. The current repo is part of the virtual monorepo. And whether this module comes from a different repo, that is part of social mode. Only if the answers for both of those questions were yes, we loaded the external source dependency. Otherwise, we kept using the snapshot dependency. And then with a very small team, like 3 developers that worked for 3 months, we were able to onboard repo by repo to the social mode, to the virtual monorepo. The process was quite transparent for our developers. They didn't really understand that they are being part of a social mode. The work included aligning the third party between all of Wix repositories, adding some runtime dependencies. Sometimes we found out that we needed to define some targets as test only. But it was all final. It was all a discrete set of issues that we were able to solve. And eventually, today, all of Wix repositories are part of the virtual monorepo. So we don't have dependencies on Snapshot. And this is basically the story of migrating Wix with polyrepo. So I bet you all ask, where are we now? So I feel like we got to a safe haven. After all of Wix repositories are part of social mode and we don't have dependencies on Snapshot, plus all of our deployables are now Bazel-based. All of the developers switched their deployables to be from Bazel. We finally announced sunsetting the old CI pipeline. So no more TeamCity, no more Maven. And we actually started deleting all the POM files. All of the developers worked with Bazel, and they're quite happy with the build times. We still have some work to do. We can still make local development better. We can still make the builds a lot faster. We still need to work on the process on updating third-party dependencies, updating our rule set. But finally, I feel like we're on after steering through choppy water, I feel like we're on a safe haven and we can start walking through the golden castle of perfect build system. So those were the 6 lessons that we learned at Wix from migrating to Bazel. I really hope that some of this can be helpful for you too. Thank you very much.
Thank you, Or. Thank you, Or. That was great. I really appreciate it. Questions for Or? Let's line up to the mic and the other mic. Thanks for making the flight all the way from Tel Aviv and everybody who flew in from around the globe. So I think it's fantastic. Let's start down here.
Hey, I'm Robin Nabel. I work for Improbable in London. I would like to hear about the measurement statistics that you were showing. You were showing a dramatic increase in stability. Now, we had the same statistic, but it's very misleading because if you have any transitive dependency that is rarely built, it always gets cached and it's like flaky behavior. Then only the top-level dependencies, like the top-level targets, will actually show you that these transitive dependencies are flaky. I was wondering whether you have any thoughts on this or whether you've encountered this as well.
So it depends if you're talking about second-party dependencies between the different repos, or the third party. For second party, we also included a pre-check mechanism to check that you don't break other repositories.
What I mean specifically, if you have a badly cached system, you're likely to rerun the exact same code multiple times, and then you will have a statistic on the number of failing tests. If you now don't change that code frequently, you will hit the cache 95% of the time. You will run this test once per month, so you won't see that that code is actually only flakily passing, because as soon as you have a passing test, you will never run the test again. I was just wondering whether you've encountered that or thought about it.
Not really. Regarding flaky tests, we do run a test twice more if it fails, and then we just declare it as flaky, and we have a mechanism to deal with flaky tests. But when the test is flaky but pass, that's a different solution that I think it's part of the work that we still need to do in order to make the system better.
Got it. Thanks.
Hi, I'm Krishna from VMware. Do you have any pointers for the dev experience that you ran into, and what are the things you learned? Basically with IntelliJ and other stuff.
So basically, go to Itai Zeidman's talk tomorrow. But we had issues with IntelliJ. We had issues with adding new dependencies since we moved from Maven granularity to fine-grained granularity. Then we had to deal with a lot more dependencies. Whenever someone extracted a class to a new folder, even if it was inside the old Maven module directory, they had to generate a build file and change dependencies. All of this became very complex, and we had to we had to create tooling for the developers to make it a lot easier.
And for the dependencies, you had external tooling to make sure the versions are not getting into trouble.
Yes.
Okay, thanks.
Hi, Alex Niederberg from Capital One.
Hi.
You mentioned some of the benefits of the remote cache. We've done some initial testing and seen that there's kind of a network penalty, especially for any infrastructure that's in the cloud. Can you talk about how you optimize for things that'll build quickly locally versus getting a remote cache hit?
It's a great question. So for local developers, we establish a cache that is only for developers, since they were using Mac and local builds, and we found a way to segregate each group of developers according to the tooling, the version of tooling they were using. And also there we found that on some targets, on some actions, it doesn't really work well to work with the cache. So we found a way to exclude those actions from the cache, so they're built locally. For CI builds, we still use cache for everything. We need this cache because we also query this cache at the end of the build in order to extract our deployables.
And the remote cache for CI, is that fairly local from a network infrastructure perspective?
Yes, it's very local.
Thank you.
Thank you.
Hi, Or. My name is Kyle from LinkedIn. So my question was about lesson 4 on your slide where you had parallel CI pipelines. Was it possible for you to do binary comparisons of the outputs of the 2 CI pipelines in order to validate that Bazel was working correctly, or were there just something about the nature of your deployable or the built artifact that didn't allow you to do that?
So we actually wrote a custom Bazel rule to generate the same deployable as Maven did. We had a custom assembly ruling for Maven, and we had to write a custom Maven rule for Bazel. But it didn't generate exactly the same binary. It was in a different structure with more jars because it's more fine-grained. But there were cases that we did need to compare in a class level. So we extracted all the jars inside, and we made sure that all the class levels are the same.
Right. Thank you.
Hi, Kyle Cordes.
Hi.
So at the beginning, prior to your change, as new developers would have been onboarded, Java developers, 90% plus are going to be familiar with Maven on their first day, from their previous work. And, right now, if you hire random Java developers, very few are familiar with Bazel. How is your onboarding going for new developers post this change?
Amazing question. So at Wix, we have a process, we call it nothing to prod. It's basically documentation of how to write your own first service from scratch, and how do you work with the CI system. And we completely changed this process in order to support Bazel development, and then for a new developer to understand how it's like to work with Bazel. It's not perfect, but it's a lot better than when we just moved to Bazel. When we just moved to Bazel, we just didn't think about this guide. And now I think this guide can be improved, but I think it really helps us. I think one challenge that we have in the Bazel community is that we don't have a lot of information in the internet about Bazel. So we really have to introduce a lot of internal information. We have our own private Stack Overflow with tons of questions about how to use Bazel and how to use Bazel with IntelliJ and how to understand the builds on CI. And this is how we support it. All right. No more questions?
Anything more for Or? Well, this is fantastic. It was a great talk. I really liked it. I love your slides. Let's have a big round of applause for Or. Thanks so much.
Thank you.